Welcome everybody to Dreamforce webinar in incorporating preventive and predictive capabilities within the IoT area of operations and products. We are recording the session so that if people would like to get a copy of it later, they can go and reference that with their colleagues. So Ryan, if you can go to the next page, we'll get started. So the agenda for today is we'll talk a little bit briefly around Dreamforce and who we are and what we do. And then we'll get straight into the topic of concept of the predictive and preventive capabilities. And then we'll actually demonstrate a use case. Ryan is going to demonstrate that for you. Then we'll open it up for questions. So on the next page, we'll talk briefly about Dreamforce. Ryan, if you go, there we go, one more. All right, so Fred Bellio, co-founder and managing partner. We've been in business for 5 years now, have been in this arena for the past 30 years, both on the PLM side as well as the IoT, both on manufacturing and connected products. Carl?
My name is Carl Wentland, co-founder and a managing partner at Dreamforce as well. Been working in the IoT space since the better part of a decade now. Helped deliver a first suite of connected appliances to Consumer Electronics Show back in 2013, and been working hard at IoT ever since. Ryan?
Right.
Yeah, Ryan Slaw, electrical and software engineer. I've been working in the space for the last 20 plus years, starting out at national laboratories and working with SCADA ICS systems a lot, transitioning over to IoT, working in the embedded market space. I go anywhere from schematic capture, software development, to layout of boards, and full system integration.
All right, thanks. So let's go on over to the next page. We'll do a brief introduction of who we are. So Dreamforce is made up of a team of technology as well as industry leaders. All our team is pretty much focused on two things, both PLM and IoT. Today we'll be talking about connected operations. We do also connected products, and we do have a practice around cybersecurity because we understand the importance when you start connected your factories as well as starting to connect products on how much you have to manage that risk for the world of cyber intrusion, I'll call it. Go to the next piece. Yeah. What we do typically is we kind of look at things holistically. So we've been with a lot of companies, we're working currently with a lot of companies, and what we find is a lot of the IoT initiatives have started as I call it a point of reference or proof of concept. And what happens is they kind of get stuck in that proof of concept. Our approach is a little different. We kind of want to walk back to the very beginning and understand what's it going to take for a company to not only be successful in the proof of concept, but understand what are the changes they need to make both within their product development organization, their manufacturing organization, their service organization, as well as how do they extend into ecosystems that exist today, like the home ecosystem with Alexa and Google. So we kind of bring you from the beginning, understand how you want your business to run, things that'll need to change within your business, the impact to your business, as well as how do we orchestrate that development of the product and the operations to support a connected environment. We have very good experience and expertise in these areas, and we kind of make sure that you feel like we're part of you, because for the last 30 years, that's who we've been. So we have worked in organizations just like your own. So with that, Ryan, if we go to the next page. So right now we'll talk about, what is the concept of today that we're going to kind of go through. A lot of initiatives as we talk to organizations is really about focusing on overall operational efficiency in the actual operations and production. If you think about it from a competitive edge and you think about it from how do you manage your organization internally here in the United States or North America in comparison to, I'll call it India, China, from a third world country when it comes to manufacturing perspectives and the cost of that, operational efficiency is key to driving, I'll call it successful business. The other thing that we'll look at briefly is also as we go into these things, we try and understand a couple of different concepts. One of them is understanding the process and the asset that you're trying to understand, and understand how you can get to the point of predicting failure, or I call it getting close to failure. We also want to make sure we kind of think about what are the parameters we need to measure when it comes to understanding that asset, so that we've got the right key characteristics that we're going after, so that we can make sure we can actually predict the actual use case of failure. And then the last thing is really, we want to have a learning environment that we're developing in. So as we see trends occurring, as we see things and anomalies come into place, how do we start rationalizing the symptom into a solution set, so that we can help the environment stay, I'll call it, up and running at 100%, wherever possible. So that's what we're going to go through today. Carl, I think the next one's yours, or am I mistaken?
No, you're not mistaken. Hi, this is Carl again. I'm going to briefly talk through your overall solution architecture for a typical connected product, whether this connected device, and I'm going to read from the connected devices on the left and work my way across the screen. So whether your connected device is a CNC machine or a 3D printer, or potentially even a box that captures metrics on your truck driving down the road, or a washer or dryer that's in a laundromat, right? The whole concept here is we're going to add some connectivity to this device, whether typical Wi-Fi or cellular. We're going to add some sensors to it for the metrics we want to capture, and then we're going to decide how we're going to power this application. Most cases, you're going to wire that to regular electrical power, but it's also pretty common nowadays that you'll use a solar solution with a battery. So concept is we want to do some command and control between the device and the cloud, and we want to capture sensor data so we can make decisions based off of that information coming off this connected device. So if we're moving to the middle of the screen, your typical IoT platform is going to have a bunch of different components. Device management, more or less, is that virtual data model of the connected device. You're going to do some data management on all the data that's coming in, some post-processing of it, so you can make some decisions and report on it later. I think the most important component is the analytics piece. What's your next best action based on the information you're getting? If you're seeing some kind of disruption in power, you can maybe infer that a motor might be having an issue. Or if you're receiving some other information around the cycle time of your device, maybe you'll know your CNC machine needs a new bit on it before it breaks. So we're trying to use this information to make better decisions and preventative type decisions ahead of time, to keep that device running optimally and adding value downstream. So beyond that information, now we start prepping the information with business logic, so we can get to your visualization layer, and we can raise notifications, allow different people into an admin portal, some kind of user app. Could be a mobile app like an iOS or Android app. Or maybe you have a lot of service techs that need specific service apps when they go out in the field to fix different issues. And then moving up to the partner ecosystem, once you have a connected device, now you have the ability to partner in with a third party to maybe get some advanced feature set or other information, such as maybe partnering with a utility company, so your factory can help respond to a demand response event in case the electrical grid needs some help. Or maybe your 3D printer is starting to run out of material, so we can automatically auto-replenish that as soon as we know that we need more fill for the next printing cycle. And there's other things, payment services, sharing data. Maybe I have a temperature and humidity sensor on one of my devices, and I want to compare that to weather data coming from a specific zip code, right? So those are typical examples of the partner ecosystem. And last but not least, we all want to integrate this information back into our back office, utilize tools such as identity management, our existing data warehouses and data lakes, maybe push some of this information upstream to the CRM or back into product development through your PLM system or your operations with ERP. So that's your typical reference architecture that can be applied depending on the use cases that you pick to go forward with. And with that, I'll hand it back over to you, Fred.
All right, thanks, Carl. Ryan, if you go to the next slide here. So what we'll talk about in brief is really the components that you need to put in place to derive an environment that is capable first of acquiring the data. So typically, we call that SCADA. It's really trying to get information from the assets or equipment that you're trying to interpret the information from. A lot of factory floors have had this for decades. The challenge has always been is extracting that information from the local machine and making that available to an environment where we can interpret and actually utilize that data, both to understand what's occurring, but also to understand where is the trend of that machinery or asset performance-based being at that time. We go to the next slide, we'll talk about the environment. And I just called it the environment, but in reality, there's a lot of use cases that companies talk about. Well, we have a cloud platform. We'll talk briefly about the cloud platform going forward, but there's so many use cases about, if you think about an action and or event-based system, when you're looking for information and based on that, you need to do something. The lag time of taking that information from a factory floor, pushing it to the cloud, and then asking for a response sometimes does not support the use case. So sometimes you got to start figuring out what are you going to do in the environment itself of the factory. Edge computing seems to start making a prominent ask for the companies to understand, how do I create a use case that can be responsive to the process I'm trying to execute at that time? So I just wanted to bring that point up, because sometimes it's just not the cloud platform. You got to create an interim kind of solution to provide feedback at the local area. And then the third piece is really around, we talked in the first one about, hey, we've had SCADA for a long time, but it's really, what do you need to be able to take that information off the machine and share it with your environment, with your business rules, with your visualizations? It's all coming down to a communication protocol and broker. Typically, we see a lot of use of MQTT. There's still some proprietary ones out there, but the MQTT broker seems to be the prominent way of communication. And then on the fourth piece is really around the cloud. And we look at the cloud for a couple of different things. We have storage of this information, historical versus, current information. We have to do data processing as we go and grab all this information from different assets to understand what do we have in the environment, for example, of an assembly sequence in a factory floor. And then we also kind of look at it from, how do I solve the challenge or the use case I'm trying to drive? So we call that business logic and understanding, how do I put these pieces together? How do I get the information? Then how do I provide a response? Be it to turn something on, turn it off, make a particular change in speed and feed, whatever the case may be. So we typically see that being done on the cloud platform. And then fifth and last is really trying to understand, okay, we've got all this information. So my SCADA is now connected. I get this information. It's on the cloud. I've got a bunch of business rules. I've got a bunch of key metrics and criteria that I'm pitting the performance against. And then how do I make sure that I'm getting a learning environment to understand and predict what we believe will be high availability of equipment, assets as we require, and how do we start looking at it? Because you think about, in the past, if you think about, it's always a reactionary kind of approach. Systems down, now I can't run my production this shift. A lot of times we've come to the situation where we can predict when a particular set of machinery will become not usable, and we can actually create a offline maintenance cycle before that actual machinery is used. So we actually start looking at that as a very high business value use case from an organizational perspective, but you have to have this machine learning environment to be able to do that. So those are just kind of the 5 key components. And then I'm going to pass it to Ryan, and we're going to go talk about our use case.
Thanks, Fred. Yep. So in looking at all this information, that's really what we're dealing with, is the information from the system coming in. As was discussed, as Fred discussed a lot of, the predictive nature of things when we're trying to keep things from breaking or keep things operating as long as possible, we have a few key sets of metrics that we look at. When we make those as a manual decision, you'll look at how many hours a machine has run, or how many times a machine has done a certain function, or possibly even speed of the machine, whatever it happens to be. That's where we get into this list that you see here in the asset usage. You know, how many cycles does it do? And in the environment, what does it do? Temperature and humidity, not only of the environment, but as in Carl's example of a CNC bit, what was the temperature of the motor of the CNC router, or even the bit itself, because there are some that can tell the temperatures of those devices. What are the voltage points doing? How's the battery doing on it? What are the charging cycles of the battery? Is it normalized? Is it running in an odd way, meaning it's not charging up as much as it used to? We can see those over time. With the asset tracking, you can track the wear and tear of systems. For instance, another example that Carl used was vehicle tracking. Well, how many miles has it done? What has it gone over, even in terrain? Is there accelerometers that you'd like to look at? This is really just a beginning list of data that you may want to start looking at when trying to track your systems and see what they're doing. So in our example here, we have a connected system or connected device. In this particular case, the devices are looking at physical deflection. So physical deflection of a medium, in this case, it's a plastic or even a foam or wooden medium. And we're counting the number of cycles or the distance that it travels to see what the wear down would be, what the wear of that material would be. Everything here that you're going to see in our case study is extremely customizable. This, of course, is built for a particular use case, but there are a lot of different things that you can do with these systems. In this case, we have a dashboard. Shows us all of the units that we have out there. This is, of course, of our demo system. So we have our 6 units in various locations and their various status points. Now, to kind of explain a little bit what we're looking at here, I'm going to go to the analytics portion. So these devices, what their main focus is to take distance measurements. So every so often, every so many minutes in this case, and that is, again, customizable, they'll turn on, they'll measure some distance, and they'll save that, and then later send it up to the cloud. So over multiple days, we get a data dump comprised of all the distance measurements. Now, in this particular case, this one's currently set to do every 5 minutes and then send up after a week of taking data. Once it gets to the system, the cloud system, the analytics can be applied. In this case, we are looking at distance measurements. So you see here that for the most part, in this day, this is August 21st, most of the distance measurements stayed at their nominal or normal level of 19.2. But every once in a while, we had a change of distance. In other words, the material was getting moved, getting the changing of distance from rest state to compressed state in this case. The system then analyzes that and marks these locations, counting it as an event. So it's a cycle event, or in this case, a dock event. And you have an uncycle or an undock event here. So that tells us a few things. Just in this one data dump, we get not only the magnitude of deflection, but also how many times that we consider a certain cycle of event. So you can analyze it from a predictive standpoint to say, Well, if I want to do a cumulative measurement of distance traveled, I could do it that way, or I could do it by event. In this particular case, we're doing it by event. Some other things that you could add here, as coming off of our last slide, is we could certainly add a temperature gauge to this, because the strain on this material may be more in colder temperatures than warmer temperatures. There's a lot of different places that you can put data and bring data into this model to where you can do that data science and data analytics to determine what's going on with your system. Back on the dashboard, we see a few things of indication, say service due, out of service, or in service. So first of all, an in-service model. The analytics, when you input a new device on this system, you put, hey, I want to allow 6,000 maximum events. That's it. That's when I know I have to replace this material. This system automatically takes an average dock events per week, calculates that as a running average, and does a cumulative count of dock events, but then using this running average, targeting, in this case, a 6,000 max, tells you how many days to service. And then, of course, calculates the date in which you're going to need to service that. If you see here on the dashboard, it'll actually tell us within the next 6 months, one of these is going to have to be changed. That's even adjustable as well, to where if I wanted to say every, tell me with things within 3 months or tell me within 5 months, whatever the case may be. Alerts can be placed also to send it to your email, mobile phone, text, whatever, to say, hey, this is going to need replaced, or keep a watch on this one because we're entering into a replace period. All of that is customizable on here, and even the analytics, if you can explain it in a mathematical method, you can put that in the back end of this system to allow it to calculate days before change, days before stress, using whatever data set, in this case, distance. But again, if you have temperature, if you have variance, things like that. The service due alerts you to when a service date has been passed. So in this case, this one being our model, has said, well, we've got a service date that has been passed. We want to be able to go out and fix that unit now. Obviously, from the predictive point of view, you're going to get here before we get a service date passed, or at least you'll be able to explain in the system why that service has been missed. The last one here we have is an out of service. On these devices in particular, we add things like battery strength. There is RSSI for signaling. But for instance, in this case, this one hasn't talked to us for a while, of course, being a test model. But we're not only doing preventative maintenance on the things that we're monitoring, in this case, the physical deflection of the medium, but we're doing preventative maintenance on the device itself that is bringing in this information. So before this gets down, for instance, a battery strength of 3 would tell me, well, the charging cycle didn't quite work on this one. Something went down and it probably dropped out of battery. So we can look back at the log data, and say, all right, when did this trend start? We can even put that in as an alarm, saying, once the battery reaches this threshold, or if the charging curve is a declining slope, then alert us, because we need to go out and check either coverage of, in this case, a solar panel, or a connection, or maybe a battery is starting to lose life due to environmental conditions itself. So a lot of different things that we can look at. But in this case, this one has lost connection. So we now know to go out and check that connection point. Let's see. Other than that, everything in this is, again, highly customizable, what data do you need to look at? So going back on our graph here, on our slide, whatever performance measurement you need to do, the analog signal coming in, we can pump that into this digital world, analyze it, and enable you to have that predictive maintenance method that the machine does for you, and alerts you far ahead of time when things are possibly going the wrong way with your systems, or just regular wear and tear. I think that brings us up to the Q&A.
Thank you. Thanks, Ryan. So hopefully we've kind of answered your question around, how do you get an environment within a manufacturing world to take that information from your assets and equipment, understand the key parameters that would give you a good performance for that particular usage, and then start monitoring those critical parameters and put that into a learning model so we can start predicting how do we look at failures or potential failures, and how are the key aspects that we can kind of recognize this before it actually occurs as a failure. So if anybody's any questions, I'll open it up to the floor.
Hi, I had a question.
We had a bit of an interesting thing there.
So I had a question. How could we apply the business rule engine to a shop floor use case?
Ryan, did you want to take that?
So to the shop floor use case. So going back to what Carl had said, CNC drill bit usage. So if you monitor how many times, or rather in a CNC, probably how many hours running on that material. So from the simplest of use cases is how many hours is that material, is that bit been used, then you can determine, so I'm going to maximize a bit use at 10 hours. Once it's done with 10 hours, then we're going to swap that bit. That's probably the simplest use case in a shop floor use. Obviously, you can get even more data there to even fine tune it more, saying speed of use, temperature of use, et cetera. But that's probably one of the simpler shop floor use cases that you would see.
Good. Thanks, Ryan. Does that answer your question?
Yeah, thank you.
Is there any other questions out there? All righty. So with that being the silence, I'll take that as there are no other questions. I will give this as the link once we finish the recording to everybody who was attended and who was invited. And we will provide that to you. If you have any other further questions for us, you can always send that email to me. I'll be on the actual sender of that actual link. So first off, thanks again for your time. I hope it was worthwhile for you, and we'll be talking soon on our next webinar. Thank you.